morning students. Today we'll discuss numericals and this is electric charges and fields chapter. Already content is finished and this is numerical 2 video. And see, the question is displayed. First question: a metallic spherical cell has an inner radius R1 and outer radius R2. A charge Q is placed at the center of the spherical cavity. What will be the surface charge density on inner and the outer surface? That means we know the surface charge density is charge per unit area. We'll find out the solution of this. Say there is a spherical cell like this and they have two radius. One is the inner radius R1 and outer radius R2. And there is a charge kept on the center. And you know, when there is a cavity, there is a charging by induction. So what will happen? This plus Q charge will induce minus Q on this side, and at that outer will be what? Plus Q. So very simple. This is minus Q charge on the what? Inner surface. On the inner surface. Okay. And this is by induction. Got it? Because it is plus Q, it will be minus Q. And plus Q charge on the what? Outer surface. And this is again by the induction. So we got the charges, and what is sigma? It is Q by S. All of you know surface charge density. So sigma will be minus Q upon 4 pi R1 square for the inner one, and sigma will be plus Q upon 4 pi R2 square for the outer one. So this is the answer for this case. So very simple. We got the densities in the inner and the outer surfaces. So this is question number 1. Now, there are two questions. One is related with the dipole. Depict the orientation of dipole in a stable and unstable what? Equilibrium in a uniform electric field. So all of you know what is by stable. You know the torque. Torque is what? It is P sine theta. Got it? Remember it? And when theta is 0, so torque will be 0. Why? Because P sine 0. That means P and E are what? Parallel to each other. Parallel to each other. So we can write in this way also. But when theta is what? 180, the torque is again 0, but this time what happens? P and E are opposite to each other. So they are opposite to each other. So one is stable, another is unstable. We can draw the diagram here only, that say this is the what? The electric field lines. So this is the direction of electric field intensity E. And the dipole is placed in it, and this is minus Q and this is say plus Q. Where is the dipole moment? P from minus to plus. So both are in same direction. This is the case of stable one. And we can draw for the unstable just opposite to it. The direction of electric field intensity is in the same way. It is given. This is E, but this time the dipole is minus Q in this side and plus Q is in this side. So it is opposite. So P and E are opposite, one for stable, another for what? This is for stable and this is for what? Unstable. Now there is another question. Two charges Q and minus 3Q are placed on x-axis. This is related with the equilibrium and the forces. Separated by distance d, where should a third charge 2Q be placed such that it will not experience any what? Force. But this time the charges are what? Unlike. Say there is a charge Q here and there is a charge minus 3Q here. At the distance between the two charges is d. We have to keep 2Q charge. Now we can't keep it in between because both are unlike charges. So it will be nearer to the lesser magnitude. That means it will be near to Q. So we keep 2Q here. And say this distance is what? X. So on this charge, Net force should be 0 because it will not experience. So one force will be due to this Q and another force will be due to this minus 3Q. And what will be the case that both will be equal, then only the net force. So F1 is between this, so we will calculate it 1 upon 4 pi epsilon naught 2Q into Q by what? Distance is what? X square, and then in between this 1 upon 4 pi epsilon naught 6Q square magnitude 3Q into 2Q upon what? Distance is D plus X whole square. So this will cancel out and this will go in 3 times, and this will be what? D plus X whole square equal to what? 3X square. So cross multiplication we have done, and then solve it. 2x square minus 2dx minus d square equal to 0. There will be a quadratic form it. And finally, when you calculate x will be d by 2 plus minus root 3 by 3d by 2. So this will be the value of x. So what should be the x value? Because there are two values. So x will be d by 2 common. In bracket, it will be 1 plus root 3. So this is the distance left of Q. So in this way, we will find out the distance of the charge from this Q. So this is related with the net force on 0. Okay. There's another very important question, question number 4. You can go through it. A hollow cylindrical, a hollow cylindrical box of length 1 meter and area of cross section 25 centimeter square is placed in a 3-dimensional coordinate system as in figure. And now figure I am going to draw the electric field in the region is given by 50 xi, okay, where E is in Newton per coulomb and X is in meter. Find net flux through the cylinder and charge enclosed by the cylinder. So I'm going to draw it. This is a y-axis, this is z-axis, and this is say x-axis. And there is a cylinder placed in it. This is the cylinder placed along x-axis. And from origin it is at 1 meter. And the length of the cylinder is also 1 meter. Okay. And this is the left and this is the right cross-sectional area. Electric field is along x-axis 50 xi. So we'll find out what net flux. Very simple net flux we can know. We know that flux is what? E dot S. So we can calculate. Now area vector will be in this side of this, but the electric field is in this side. Area vector is this side and electric field is also along this side. So flux from this cross-sectional area will be minus ES because both are opposite, and flux from this cross-sectional area will be plus ES. So we are going to calculate it. Minus ES, the magnitude of E is minus 50, and what is X here? From here it is 1 meter. Okay, and S is given 25 centimeter square, so 25 into 10 to the power minus 4. Similarly, phi 2 we are going to calculate. You solve it out, it will be 0.125 Newton meter square per coulomb. And similarly, phi 2 will be 50, but this time the distance from here to this is x is 2 meters. So 2 into 25 into 10 to the power minus 4. So solve it out. You are going to get it point double of this, 250 Newton meter square per coulomb. So net flux will be, that you add them, phi 1 plus phi 2, you will solve it and it will come 0.125 Newton meter square. You add them. This is in minus, this is in plus, this will be the net flux. Got it or not? And then you know that what will be the charge? All of you know Gauss theorem, phi is Q by epsilon naught. So Q will be phi epsilon naught. So finally you multiply it, what? 0.125 into what? 8.85 into 10 to the power minus 12. You know this value. So this comes 1.107 into 10 to the power minus 12 coulomb. So calculate it. This is very important question. The flux you got is this. Okay, how you got it, and this is the net charge. So this is the question which has come in the exam, and this is very important how to find. In place of some questions, you will find that there is a cube kept here. The concept is same, left and right, you add them. Left is negative, right is positive. Okay, so this is question number 4. Now come to the question number 5. And what is question number 5 is here given two small dipoles, each of dipole moment P are kept at an angle of 120 degree. E is along positive x direction. Find the resultant dipole moment. Also find magnitude and direction of torque acting on this. So this is the question which was asked in 2012 also in the exam. And what will be the solution? Two small dipoles are given. So two dipoles are given like this. One is this, a dipole is in this way, and another is this, and this dipole is like this. So two dipoles are given, and this is x-axis, okay, and the angle between the dipole is what? 120 degree. This is the picture, and E is along positive x-axis. So find the resultant dipole moment. I think all of you know dipole moment. The direction is from minus to plus, okay, and minus to plus. So there are two. One is this P1 and another is P2, but both are identical. So P1 equal to P2 equal to what? P. So do you know what is the law? You remember parallelogram law? P1 is square plus P2 is square plus 2P1 P2 what? Cos 120. So I think you put the value, it will be P1 square 2P square 2P square cos 120 is what? Minus 1 by 2. Solve it, root 2P square and minus P square root P square, and finally the answer is P. So the final answer is what? P. So this is the what? Resultant dipole moment. So one is this. Also find magnitude and direction of the torque acting on this. And I think most of you know what is the formula of torque. Torque is PE sine theta. And you know P is resultant is P, E, and what is sine theta? If you see the angle, the sine theta is actually this angle. This is the resultant of this one, and this is E. So if I ask you, this is the resultant P, and this angle, it is basically 30 degree. So P sine 30. Sine 30 is what? By 2. So PE by 2, if you see this angle, it will be what? 30 degree between electric field and what? Resultant dipole moment. And then what is their direction? Now direction will be, if you see P is in this direction, E is in this direction. So if you put the value here, it will be what? The direction of the torque, you can calculate it, that is P cross E. So this will be in the negative Z. So find out the direction. Torque is perpendicular to both P and E. So this will be, if it is y-axis, it is x-axis, then P cross E. So this is the direction. It is anti-clockwise, so it will be Z direction, and it will be negative Z direction. If you see, it moves, it is a positive Z direction, and it will be negative Z direction. Okay, now this is the question. Now the next question. Got it or not? Draw a graph between electric field and a distance for a uniformly charged plane sheet, and draw electric field lines for a uniformly charged hollow sphere. So you have to draw the graph for a uniformly charged plane sheet. Now do you know what is the plane sheet? Plane sheet We have calculated sigma by 2 epsilon naught. So if I draw between E and R, you know that this graph will go like this. Why? Because E is independent. E is independent of R. So it has no relation for what R with E. So E is independent. For this, draw electric field lines for a uniformly charged. Say this is a cylinder and this is having a charge on it like this. The charge on its surface on both the sides, and here also you will show the charge, and here also you will show the charge, and you have to draw the lines. Do you know the lines will go like this? I am going to represent it. This is the cylinder and the lines will be like this. From the surface they will move like this, okay, and then from this side also they will be like this. So outward, radially outward from the, and from this surface they will be what? Like this. So this is how we are going to draw the electric field lines. This is the side view. From the top view they are moving like this. This is the top view, like a point charge, you remember. So this is how we represent lines from this. This is independent. So this is fifth and sixth question. Very important, that how we calculated it. Now the next one is the question 7 and 8. We are going to discuss it. That a point charge Q is at L by 2. It is kept at L by 2 directly above the center of square of side L. So we have kept it at L by 2 directly above the center of the square. Find the electric flux. Very simple how you are going to find out the electric flux. So there is a concept. If this is a square of length L and there is a charge here at L by 2, do you know what happens? This charge is kept here. So you have to enclose it because flux comes from the enclosed surface. So what we will do, that we will draw another surface on top of it symmetrically to it. Do you know what it forms? It forms a cube. A cube encloses the charge. So flux through this, flux for the complete Gaussian, you know that it is Q by epsilon naught. But for square, we know that it will be Q by 6 epsilon naught. So this is the flux. Are you getting it or not? You have enclosed the Q symmetrically, and above this square there will be another square at the same distance. The whole formation will be a cube. So flux through the square will be Q by what? It will be Q by 6 epsilon naught. And in this way you can do the questions related with the cube. There are a number of questions related with the cube. And then there's a question number 8, that is 3 charges are given, plus Q, and what? Minus 2Q, and they are placed on the vertices of an equilateral triangle. Minus 2Q is here and plus Q are here like this, and they are like the, you know that they are at 60 degree. Now remember that you see that there will be two dipoles formed here. How? One is this plus Q minus Q, and one is this plus Q, and this is also, sorry, minus Q. This is minus Q and this is plus Q. Okay, so where is the dipole moment? One is this, one is this. So where will be the resultant? This one. So this is PP and this is PR. This is 60 degree. You know that this will form one dipole, this will form one dipole. What will be the resultant? It will be root P1 square P square plus 2P into P. What is the angle? Cos 60. So it becomes root 2P square plus 2P square cos 60 is half. So it is root 2P square plus P square. So it is root 3P square. The answer is, that means it will be what? P root 3. Got it? And if you want to take in the terms of the distance, you can take it in the terms of the distance. Say this is D, this is D. So P is what? Q into length. So Q into D root 3. You can write in this way also. So very simple. There are only two dipoles and you can form the dipole and you can get the resultant one. This angle is 60 degree minus, minus, plus, plus. Got it? So this is the question number 7 and 8. Now the question number 9. Now question number 9 is from the NCERT book, and this question is also very important. You see the figure and just read out the question that a particle of mass m and charge minus q enters the region between the two charged plates, okay, moving along x-axis with a speed vx as in the figure. The length of the plate is L and an uniform electric field is between the plates, okay, positive and negative. So what we have to see is that the vertical deflection of the particle of the far edge of the particle, far edge it vertical distance, an important question here. Very simple, you know that this is y, this is x-axis. Now if I ask you force along y-axis on this charge, it will be what? Do you know? This force will be, the magnitude of the force will be QE, because there is an electric field acting on this charge. So electric field is there acting on this charge, and the electric field is, say it is given here. So the charge is moving in this way. So Fy is QE. So if I ask you what is the acceleration, I think all of you MAY equal to QE. So AY is what? QE by M. The acceleration is along only the vertical axis. This is the acceleration. And Vx is given, that means initial Vy is what? 0. Got it? It is the along the V, this direction. So Vy is 0. And all of you know what is time. Time taken from here to here will be total length upon velocity L by Vx. And we all know that the relation of the kinematics is ut plus half at square. So you have to find out the vertical distance. I think all of you know y. U is what? Uy is actually the initial one. It will be 0. Okay. Plus half ay and t square. Ay is given half. It is qe by m. And time is L by Vx. What? Whole square. So finally it is QEL square by 2mbx square. So this is the vertical displacement, and very interesting is that y is directly proportional to L square. This also shows that it moves along parabolic path. So Fy is QE, the force acting on this charge. MAY, acceleration you got, initial velocity is along x-axis, initial y 0, time is this. You calculate y equal to ut plus half at square and you put the formula and you get this answer. So this is also very important question, question number 9. Now we are going to come with the question number 10. So 10 is a question which is related with a derivation. And this question, it has been asked number of times in the exam, that what is, though this is not the in the content, and you see the question, what is written here is that a charge is distributed uniformly over a ring of radius a. Obtain an expression for electric field intensity E at a point on the axis of the ring. Hence, so that for points of large distances from the ring, it behaves like a point charge. So this is actually not in the content, but this was again asked in this year. This was a question, and we'll take a ring here. So this is a ring, okay, and this is the axis, and we have taken this point here, and this is a, say, a charged ring like this, charged ring on the charge is on the ring. Are you getting it? And you have to find out on its axis, this is the center, and say this is A. This is the element of the ring of, say, dl length, and same is this. This is the element of dl length. And what do you do, that when this will have a dl length, it will have a dq charge. It will also have a dq charge. So you would join this line with this point. Join this line, this point. Say this is r distance. or say this is x distance. You will say this is r. So this way, so positive dq, the electric field will be in which direction? All of you know, in this direction. This is positive, so this will be the electric field. And this is dE. This will be dE, and this angle are same, and they are say theta. So D will have two components. One is this and one is this, and this will also be theta. So this is dE sine theta, and this will be dE sine theta, dE cos theta, and this will be dE cos theta. And the main thing is that what is dE? dE is the electric field due to this or this, and they will be the same. That will be K dQ by R, KQ by R square. So K dQ by R square, and you can write it in that form. What is dQ? And dQ is what? It will be written in the terms of what? The charge, what? Density. And what is the charge density? Is that lambda is dq by dl, you remember, and this is dq, you want to find out it is lambda dl. Okay, and how many of you know lambda is q by total length, 2 pi a. So if I put it here, it will be q 2 pi a dl. So what is dq? Is q k what? Q by 2 pi a dl by r square. So got it. This is d. Now do you know d e sine theta component cancels out? Why they cancel out? Because equal and opposite. Got it or not? So finally we have what? Only the net electric field is, I'm writing it directly, E along this, and it will be a integration of one component, d cos theta, and the integral part will be from, for the complete what? Ring, it will be 0 to 2 pi. Got it or not? D sin theta will cancel out. The integration will be of t cos theta, and you put the values of this 0 to 2 pi a, and what is this? D k q 2 pi a dl by r square, and cos theta is x by r. X by r. Cos theta is x by r. So everything will come out. Only the integration of dl and k q x 2 pi a. Okay, and this will be r square 1 upon r cube, and integration of what? 0 to 2 pi a dl. And then finally you calculate it. I'm writing here only the electric field will be the final answer, kqx by what? X square plus a square to the power 3 by 2. This is the electric field from this one. You calculate it. This is r cube. In place of r, what you are going to put is root. What is r? It is root x square plus a square. So this will be the answer. Got it? And there is written, it behaves at point charge. So large distances means that when x is greater than what? A. What do? We ignore a square, neglect. So if you put it here, you are going to get final answer kq by what? Do you know? X square. So this is very important concept. You just go through it. This is a ring. These are the two dq charges we have kept on the ring. How you calculate it? Sin theta is cancel out. Integration of d cos theta, you solve it. You'll get this answer. But when we talk about the large distances, x is greater, a square neglected, this will be the, and this behave as a point charge. You remember kq by what? R square. So this is one of the very important question. Now question number 11 and 12, and question number 11 and 12 is also very important for the exams, for the competitive exam also, and for the boards also. So what is this? Two similar balls, each of mass m and charge q, are hung from a silk thread of length L, prove that in equilibrium separation theta is the small vertical with the small angle with the vertical, and you have to prove that the separation is q square L by this 2 pi epsilon naught mg power 1 by 3. Now I'm going to draw the diagram. Say this is the vertical and this is the angle made by what? The silk thread. That is how this is there. And then this is the another way it is represented. This is also theta. And the separation between this is, say, it is simply what we are going to calculate. It is, say, x, the equilibrium separation between two balls, and two balls have charge q and q. So that means you have to calculate x, and we know that it will move on in this way, and everyone knows that this is what? Mg sine theta. This is mg, and this is what? Mg cos theta. Got it or not? And this angle is theta, and there will be a force on this direction due to repulsion. And because this is x, same angle, so this will be x by 2 and this will also be x by 2. Are you getting it or not? So in this way, x by 2, total distance is x, mg sine theta and mg cos theta are there, the forces. So what is the force between the two charges? If I ask you, it will be kq square by I square. Simply I will write 1 upon 4 pi epsilon naught q square by what? X square, force between the charges. And all of you know sine theta is nearly equal to theta will be what? Arc by radius. So what is arc? Is x by 2 and radius is L, so that is x by 2L. So this is theta. And all of you know what is the restoring force is mg sine theta. So mg sine theta will be equal to, do you know electrostatic force? 1 upon 4 pi epsilon naught q square by x square. So you put the value of sine theta is x by 2L equal to 1 upon 4 pi epsilon naught q square by x square. Got it? And finally you will get x from here will be, do you know what? It will be q square L upon 2 pi epsilon naught mg to the power 1 by 3. So this you are going to calculate y3. Some will say y3 to x square into x, it will be x cube. So solve it out, you will get this. And the last one is very simple, and the last one is that this is the two charges plus 4 microcoulomb plus 1 microcoulomb. They are separated by 2 centimeter. Find the line joining where the net electric field will be 0. Somewhere near this 1 plus 1. So say this is x. This will be what? 2 minus x. So net electric field will be this. The direction will be E1 on this side and E2 will be on this side, away from positive charges. So magnitude will be equal. Okay. E1 and E2 will be what? Equal. So KQ is 4 microcoulomb by x square, and KQ is what? 1 microcoulomb by 2 minus x whole square. So K cancel out, micro, and this is 4 by x square equal to 1 upon 2 minus x whole square, and this is 2 by x will be 1 upon 2 minus x. So this you have calculated, and then multiply it cross. So it will be 4 minus 2x equal to what? X, and it will be 4 equal to 3x. So what is x? 4 by 3. 4 by 3 from plus 4 microcoulomb. So this is 4 by 3 centimeter. So in this way, very simple question. This is the 12th question. So these are all the numericals. You go through them and find out. If you get any problem, you can WhatsApp to me. And thank you for watching my video.